Let's take a look at number 5, where f is the arc cosine and g is x squared. H is the composition, f of g. Therefore, h is f of x squared, which means h is the arc cosine of x squared. All right, so now we know that h is the arc cosine of x squared. So let's find out where x has a relative maximum. We'll set h prime equal to 0. So we have a formula for the derivative of our cosine, and it is the opposite of u prime over the square root of 1 minus u squared. So u is x squared in this function, so u prime will be 2x. So h prime of x will be negative 2x over the square root of 1 minus the u function x squared using the formula. So that simplifies to this, but we're setting it equal to 0, and fractions are equal to 0 only if the numerators are 0, and the numerator is 0 when x is 0. So is there a relative maximum here? Let's use the first derivative test. Our number line represents values of x. Our critical number was x equals 0. And we say that the sign of h prime is positive on the left, and then it becomes negative. Or if you read the answer key, it doesn't have a picture. It just says h prime changes from positive to negative about x equals 0. By the first derivative test, there's a relative maximum at x equals 0. Part B, find the area bounded by the horizontal line y equals pi over 3 and function h, the inverse cosine of x squared. So this is a calculator problem. You could just enter this and this equation and see what the region is that they're talking about. In case anybody tried to do this without their calculator, this is the process you would do. But let me reiterate, this problem was meant to be done with a calculator, so you didn't need to follow along and graph this without. But just for giggles, or just to satisfy anybody's curiosity, to graph the arc cosine of x squared, we'd start by looking at the graph of cosine, and then we would graph the arc cosine by restricting the domain just to the place where it covers all the values in the range and passes the horizontal line test. And then if you take these ordered pairs that define the 3 benchmark points on this curve and invert them, we get the graph of inverse cosine. But h is the inverse cosine of x squared. So that means as the x values go to the left, you're squaring them, you get the exact same output as if you had gone to the right. We have this reflection symmetry over the y-axis. So what you see on the right just gets reflected over to the left. The maximum is at pi over 2, and we know that pi over 3 is a little bit smaller than that, so the horizontal line comes underneath. And so the region that we're trying to find the area of is that green region. All right, well, to do this, and to set up the expression that represents the area, we need to know P and Q, the x values that define where the integration will start and where it will stop. So if we set the yellow curve, the arc cosine of x squared, equal to the blue curve, which is pi over 3, take the cosine of both sides, then x squared is cosine of pi over 3, and x is positive or negative 1/2. Because we know that cosine of pi over 3 is 1/2. Okay, what next? We're ready for the area. So there's a lot of ways we can write this one. We could say from negative 1/2 to 1/2, do the definite integral of the cosine function, which is the yellow one, minus the blue function, which is pi over 3, and that would do it. Just as correct would be if we had gone from 0 to 1/2 and just did the right half and then doubled it. That would be fine. We could separate the integrals if we wanted. We could do it like that, from negative 1/2 to 1/2 of the yellow curve, and then subtract just under the blue curve. These are all equivalent, and you can see that in the answer key, they even simplified it a little more and just said h of x. That was acceptable. All right, that's how you do number 5, part B. Onward to part C. for the last part of number 5, they ask us to evaluate the derivative with respect to x of the inverse function. That's equivalent to saying, what is f inverse prime of pi over 3? So for this one, you'll definitely need to know the formula. F inverse prime will be 1 over f prime of f inverse of that x value. So remember, within the function and its inverse, x and y just swap. So we need two things. We need the derivative of f. We also need f inverse at pi over 3. So to find f inverse of pi over 3, when we compare the function and its inverse, we're looking for the output when the input is pi over 3. That is, what's the output when the input is pi over 3. So we can invert these to function f, and this input becomes the output. Finding f's input, which gives us pi over 3, will find us the inverse's output. So we're looking for the input to f, which is arc cosine of x. What's the input, which gives us an output of pi over 3? Well, we know that the ratio that gives us an angle of pi over 3 is 1/2, because cosine of pi over 3 is 1/2. So our answer here is 1/2, so the output is 1/2, so this yellow value is 1/2, so our denominator is f prime of 1/2. So what is f prime? Well, for this one, since it's an arc cosine, the derivative is the formula, -1 over the square root of 1 minus x squared. So our x value is 1/2. That's what we're putting in there. Let me write that down. So we have f prime of 1/2, which is -1 over the square root of 1 minus 1/2 squared, which is 3/4. The square root of 3/4 is the square root of 3 over the square root of 4. And this is negative. 1 divided by this fraction is its reciprocal. So we have -2 over root 3. F prime of 1/2 is -2 over root 3. And then again, when we do 1 divided by that, it'll be the reciprocal. And there is our final answer. I hope this helps. This was number 5.